Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video I'll go through this atomic structure, which is book 1 for for the class that I'm teaching, which is the students who are going to sit for the 2023-5070. This is the chemistry O-level for the Cambridge International Exam. This is equivalent to GCSE or IGCSE chemistry curriculum. Whether you're doing a core or extended paper, atomic structure is an important topic regardless. So in this question, we have these terms that we have to classify a few substances: elements, compound, and mixtures. And we know that elements can be further divided into metals and non-metals. These are elements that you can find in the periodic table, and the metals tend to be found on the far left of the periodic table. And of course you also have the transition metals, which from the name itself, they are transition metals, they are transition elements, they are all metals. And the non-metals are usually on the far right of the periodic table. So these are just a bit of generalization, and they are not necessarily like, you know, word by word whatever it always is. Okay, it's just a general idea. In terms of definition, so any chemistry student should be able to tell you a little bit about the definition for each element. So any chemistry student who fails to do this means that you don't really understand chemistry at all. Okay, so an element is a substance that you cannot break down into any simpler substances by chemical method. That's because they only contain one type of atom. Okay, so an element is a substance containing only one type of atom. So there's only one kind or one type of atom, only one type of one kind, and it cannot be broken down, into simpler substances by chemical method. So chemical method is usually quite a harsh method, requiring a large amount of energy to transform from one form to another. And if you can't do it even by chemical method, that means it's impossible to actually do it, at least in chemistry. Okay, so a compound, on the other hand, a compound consists of two or more atoms chemically combined together. It's a substance that contain, or you can say consists of, two or more elements which are chemically combined together. And what is important is that for a compound, they're chemically combined in a fixed ratio. That's why when we have a formula of a particular compound, there exists as like how many atoms of this particular element and how many atoms of the other element. Okay, so because of the 2 marks for each of these, it's important for us to specify as much information as possible. So these are further characteristics of a compound, chemically combined in a fixed ratio. And you can of course also talk about the properties of compounds being very different from its constituent elements, or from the elements that are used to make up the compound, right? So for the 1 mark for mixture, so mixture is made up of, or you can say consists of, is the same thing, consists of 2 or more substances. Why do we use the term substances now and not elements? Because you can have element plus a compound, or you can have element and element, different element combined together, mixed together, or you can have different compounds mixed together. Okay, so it can be elements and or compounds. So it doesn't matter how you mix them together, it's still going to be a mixture, right? Mixed together. So it's just mixed, they are not chemically combined. Okay, so hence, because they are not chemically combined, the ratio of these substances is not fixed. Okay, is not fixed, or you can say it's not defined. It's not a fixed number, it's not a defined number. Okay, so the components can also be separated easily as well. So we need to classify each of the following substance as either an element, compound, or mixture. So brass is an alloy. The definition of an alloy is a mixture of metal, and brass is made out of copper and zinc, if I'm not mistaken. And because it's a mixture of metal, very clearly it's a mixture. Okay, carbon dioxide has a proper formula, CO2. I'm sure if you read the news or whatever, you will have heard that there's an increase in the amount of CO2 in the atmosphere that results in global warming and uncertain weather patterns all around the world. And this has a fixed ratio of carbon is to oxygen, 1 carbon and 2 oxygen, and this is a compound because it consists of 2 elements, 2 or more elements chemically combined together. Copper is a metal and is a metal in the transition element block, and transition element is also the transition metal. So it is a metal, and when it is a metal, it is an element, okay, because you cannot break it down further into simpler substances. And you can also find copper as element number 65, if I'm not mistaken. Let me have a look at my periodic table. Copper is element number 64, okay, in the periodic table. Which physical property, so you need to read the question, physical, not chemical, okay, so it's got nothing to do with chemical property or chemical reactions. Which physical property is used to distinguish between metals and non-metals? It's possessed by all metals, but by only one non-metal. Okay, it's possessed by all metals, but by only one non-metal. So we know metals can conduct heat and electricity very well. So we said that this is to do with heat, or you can call it thermal. Thermal. Do I want to say heat conductivity? That's all. Maybe I can just say conductivity of heat and or electricity. So if you can conduct electricity, that means you allow current to flow through. Okay, so all metals can do that. So carbon graphite is used in your, specifically graphite, yeah, not the diamond form, in battery electrodes. So the reason we use them as electrodes is because graphite can conduct electricity, and it is the non-metal that can conduct electricity very well. So that's why it says possessed by all metals, but only one non-metals, and carbon is actually a non-metal. Okay. So that was it with question 1. Question 2, a lot of wording. So we have S being the same number of, and then D being a different number, more represented by M, and F is fewer. Fewer actually means lesser, just in case you don't know what they mean. Okay, so 2 atoms of the same element. So if they have the same element, 2 atoms of the same element have same number of protons, and it must be same number of electrons because they are atoms. So again, we are talking about electronically neutral, or you can use just the term no overall charge because we are talking about atom. So if they have no overall charge, so they must have the same number of protons and electrons, right? Compared to its atom, you get a positive ion because you have more protons. You have more protons. So definitely, when you have a positive ion, you have more protons than neutrons. The number of proton is greater than the number of electrons, right? Not neutrons. And then for negatively charged ion, you will have electrons more than the number of protons. But then, based on these sentences, the positive ion has, well, I guess I can say more proton, fewer electrons. That one has fewer protons and more electrons. Just playing around with words after you know the relevant idea, rather than playing around with words without knowing the relevant idea. That is more difficult. Yeah, 2 isotopes of the same element. So same element would mean same proton number, because proton number is the identity of the element. So they will have same number of protons but different number of neutrons, because the mass number will be different for isotopes. All the atoms of uranium-235. So this is a specific isotope, all right? Specific isotope. And uranium is, if you have a look at your periodic table, uranium has the symbol U. It's element number 92, so I can write it in this form: the mass number on top, the uranium-92 at the bottom. Okay, but then obviously in your periodic table, they always show you the proton number on top and the mass number, the relative atomic mass at the bottom. But this is the specific isotope, so this is actually the relative isotopic mass. Yeah. What can we say? The proton is going to be 92. The electron is going to be 92 because they specify atoms. All right, atoms meaning the number of protons will be balanced by the number of electrons, because overall there are no charge, and then the number of neutrons would be 235 minus 92, so there's 3, that is 133, I think, 1 2 1 3, hang on, let me see, 143, yep, 143 is correct. But then again, it's not a fill in the number, it's actually complete the statement by writing each of the letter. So 92 electron versus 143 neutrons. So you have all atoms of uranium-235 have all the atoms of uranium-235 have, well, all the atoms will have the same number of neutrons, because they are all uranium-235, so all of them will have 143 neutrons, and all of them will have 92 electrons, because all of them are atoms, and all of them will have no overall charge, and all of them will have proton number 92, so you have 92 electrons. So hang on, they will have same number of electrons. I'm filling in the blank, I'm following the instruction, alright? I hate this kind of question actually, but anyway. Compared to atoms of elements in period 3, so period 3 is actually sodium all the way to argon in your periodic table. Period 2 is lithium all the way to neon. They will have lesser proton, and then they will have lesser electrons, because, you know, second period, lesser protons, because they will fill before you go to period 3. Question 3 is about, well, this is where we need to start counting the number of protons, the mass number, the number of proton, electrons, and neutrons. So this element is also oxygen, and the identity of the element is the proton number, so it's proton number 8. The nucleon number is also the mass number, which is 18. So this is also the mass number. There's 18. 8 protons, 8 electrons, 18 minus 8, because nucleon number minus the proton number, you get 10, right? So this is carbon. The proton number is 6. That's the identity of the element. The nucleon number is a number on top, so there's carbon 12. Proton number is 6. The electron is going to be 6, because we are talking about an atom, not ion. And this is going to be 12 minus 6 is 6. Okay, so very quickly now, carbon 6, 13, 6 proton, 6 electrons, because 6 proton, 6 electron because it's an atom. But the number of neutrons are different, because these are isotopes, atoms of the same element with the same number of protons but different number of neutrons. Okay, so this is magnesium. At the bottom is also magnesium. Both are the same element, both have the same proton number, 12, if I write that properly. Nucleon number here is 24, here is 25. Proton number is the same. Number of electrons is the same, because both are the same element, and also both are atoms. Okay, so number of proton equal to number of electrons when you have atom which are not charged. 24 minus 12, mass number minus proton number, you get number of neutrons. 25 minus 12, you get 13. The next bit is a bit tricky, because they just give you the detail, but remember this is proton, electron, and neutron. So proton number is the identity of the element, If you look at element 17 in the periodic table, you will see that that is chlorine. The proton number tells you the identity of the element, so we have to write down the symbol like this. We have to put the mass number on top and the proton number at the bottom, so there's 17 and 17 at the bottom. This is the nucleon number, which is the mass number, which is the sum of the proton and the number of neutrons. So 17 plus 18, 17 plus 18, number of proton plus number of neutron, that's 35. 17 plus 20, that is 37. So this is chlorine 35, chlorine 37. This is the way you write it. Mass number on top, proton number at the bottom, the symbol of the element. When you pronounce it, this is called chlorine 35, chlorine 37. Magnesium 24, magnesium 25. Carbon 12, carbon 13, and so on and so forth, okay? Question 3, we know that these are ion. We need to give the formula, and you can see that the number of electrons does not equal to the number of protons. So from here to here, you gain 1 electrons, therefore minus 1 charge. The number of protons is the identity of the element. So you look for element number 9. Element number 9 in the periodic table is fluorine. The symbol is F, so it's F minus. And I have to put in number 9, and then I have to put in the mass number, which is to do with number of neutron plus the number of proton. 9 plus 10 is 19. Okay, so how I get 19? Mass number equal to proton number plus neutron number. I give the mass number on top, proton number at the bottom, symbol of the element, and the charge of the ion. Okay, element number 16 is sulfur. Okay, element number 3 is lithium from your periodic table. Element 20, proton number, so that is calcium. So this is, well, from 20 electrons to become 18, so you have lost electrons. In fact, lost electrons times 2, so it's going to be calcium 2 plus 40. I get 40 is the mass number because proton number plus number of neutron give me the nucleon number. So this is how you write them properly. Yeah. Let me use a different color for the other one. 16 to become 18, so gain 2 electrons. This is sulfur. It's a 2 minus. It's element number 16, and it has got 32 nucleons because 16 plus 16. 3 plus 4 is 7, so it's 7. The proton is 3. The element is lithium, Li. From 3 electrons in the atom to become 2 electrons in the ion, you would have lost 1 electron, and therefore you just have a plus 1 charge. Okay. In this question 4, so this is about 5 atoms, P, Q, R, S, and T. So these are not their actual chemical symbol, to avoid your confusion between phosphorus or sulfur with the character P and S that are being used for this particular question. So we need to complete the table to show the electron distribution in terms of how many electrons occupy the first shell, the second shell, third shell, and the fourth shell where it is appropriate. Because these are atoms, that means the overall charge is 0. Therefore, the number of proton equal to the number of electrons. So be aware that I can use hashtag to represent number of proton and number of electrons. But unfortunately for you, you would have to write them out in full, in words, okay, instead of using hashtag like me, okay? So that better be clear. You need to write out the number of proton equal to number of electrons. In an atom, due to the overall electrically neutral charge, meaning to say the overall charge is 0. So that means the number of electrons, if I total number of electrons would be equal to 2 there, 4 there, 13, 15, and 19. And we know that the first shell can accommodate 2 electrons maximum, and second shell can accommodate electrons maximum. And for the sake of simplicity, at least for the first 20 elements, the third shell can occupy electron maximum. And then the fourth shell can occupy more than that, but we could worry about that later on. So if you look at element number 2, the 2 electrons will occupy the first shell and nothing else. So it's just the first shell 2. That is the configuration for helium. Element number 2 in the periodic table. When you have 4 electrons, then you could occupy 2 maximum in the first shell. You are left with 2 in the second shell. When you have 13 electrons, you have 2, 8. So 2 plus 8 is 10. You need 3 more to go up to 13. So 3 in the third shell. So when you have when you have 15, you have 2, 8. So there's 10, and you need 5 more. And you still haven't reached the maximum for the add electron maximum in the third shell. When you have 19, you have 2, 8, 8. So there's up to krypton. Is it krypton? No, there's up to argon. Okay, so 2 plus 8 is 10, 10 plus 8 is 18, and you have 1 more in the fourth shell to bring it up to 19 electrons, which is element number 19 is potassium. So it's the fourth period, and it's in group 1 because it's got 1 outer shell electron. So looking at the option, how many valence electron does atom R have? Valence refers to outermost shell electrons. So looking at R has 3 electrons in the outermost shell, so it's in group 3. So there's 3 valence electrons. Okay, how many of the atoms are from period 2? Period 2 of the periodic table. Period 2 would mean the outermost filled shell is in second shell. So this is a first period element because only the first shell is filled. This is a second period element. This is not a second period element because the outermost electron fill in the third shell. Same with this. These two are period 3 element. This is a period 4 element. So how many of the atoms? How many? Read the question. So only 1, or you can say 1. Even though the answer is actually 1, but they could ask which atom is from period 2, then there will be Q. All right, but Q is not the answer here because how many of the atoms? You got to read the question. Which 2 atoms? All right, so which 2 atoms belong to the same group? Belong to the same group of elements. Do I really have a same group of elements here? Which 2 atoms belong to the same group? Let me think. Have I made a mistake? 10, 15, 10, 18, 19. Which 2 atoms belong to the same group of elements? So just by looking at the options given, you can tell that none of these elements are in the same group, okay? In reality, they actually have a typo in the question. This shouldn't be 19, this should have been 20. And then if this is 20, then this will make sense for this to be 2. And then only then these 2, sorry, not these 2, okay? This and this, not this because this is a noble gas and this is in group 8. Whereas this is in group 2 and this is also in group 2 if this is 20. So we are looking at element Q and T and not P. And this is trying to confuse you because this is a noble gas, but helium being in the first period can only occupy the first shell. There is a maximum of 2 electrons only. Okay, so this is not in group 2. So draw a diagram to show the arrangement of the electrons in atom T. So in atom T, your configuration is 2.8.8.2. All right, so that is going to be, if you draw the first shell T, first shell 2 electrons, draw the second shell, 8 electrons. I mean, my circles are not perfect, but you know, they are better than some of the worst one that I have seen. All right, so the electrons are always moving around, so it really does not matter if I put them in pairs or not. I just like to put them together like this, but in reality the electrons are always moving around, and the structure of an atom is not 2-dimensional like this, but in reality it's 3-dimensional. So they're moving around in a region or sphere called the energy levels. Okay, but essentially this is 2, 8, 8, 2 electronic configuration for 20 electrons filling up to the fourth shell, 2 electrons in the outermost shell, group 2 element. Next question, which of these is not an element? Not an element. Carbon dioxide is CO2. It's got one carbon and two oxygen atoms bonded chemically together. So A is actually a compound. Okay, nitrogen exists as diatomic molecule. These are some of your common vocabulary that you got to know already from your diffusion, from going through diffusion questions in topic 1, and you will understand more of them in structured and bonding. Okay, so only one type or one kind of atoms. There is no other kind of atoms, even though there are more than one atom, but they are of the same kind, both nitrogen, both oxygen. So only carbon dioxide is a compound there. Nucleon number is the sum of the number of protons and the number of neutrons, so very straightforward. It's also known as the mass number. So you add up the number of protons and number of neutrons. A stable atom, meaning not radioactive. Radioactive element. Radioactive means unstable nucleus. Okay, unstable nucleus. If your nucleus gets too big because of too many protons and too many neutrons, you become unstable, and then you want to break down into two smaller nucleus with different, with lesser number of protons and lesser number of neutrons. So a stable atom would have equal number of, well, it's hard to say, right? You would say a stable atom would have equal number of protons and neutrons, but that is not entirely true for every single thing. Okay, so based on what I just said, is to do with whatever is in the nucleus, which is the protons and neutrons. But there are some atoms that are stable. They are not necessarily equal. So A is actually there as a distraction to try and confuse you. The neutrons and electrons are not going to be balanced out, okay? But the protons and electrons have to be balanced because it's an atom, okay? The keyword there is atom, and when you see an atom, you know the number of protons equal to the number of electrons, and that's why there are no overall charge for an atom. The atomic number of carbon. The atomic number is the same as, well, you can say it's the mass number or the nucleon number. So the one that say is the atomic number is the basically the same as mass number and nucleon number. So it's going to be 12 as shown in the periodic table, or at least in your periodic table you will have seen it as like this. Okay, so this thing at the bottom is what you call relative atomic mass. It's also known as mass number or nucleon number. It's also known as atomic number. So it's got a lot of different names. They're basically saying the exact same thing. Next question. So we are looking for a species where the number of electrons and neutrons are equal. So some of these are atoms, but some of them are ion. This is a positive ion. So the number of protons is more than the number of electrons by 1. The number of electron is more than the number of proton by 2, because the electrons, you gain 2 electrons, you lose 1 electron there. Okay, so if I were you, I would go on and set up the proton, electrons and neutron kind of imaginary table. So the proton number is 4 because it's element number 4, proton number is 9, proton number is 11, and proton number is 8. These are the identity of the element based on their proton number, as you would have known from periodic table. This is an atom, so the number of electrons equal to the number of protons, because there are no overall charge to an atom. This is the +1 charge. That means you have lost 1 electrons, so that's why you have 1 extra proton, then electron, that's why you have a +1 charge. Here you have to gain 2 electrons, so you have 2 extra electrons than proton, that's why you have a 2- charge on the ion. A nucleon number, or the mass number, take away the proton number will give you the number of neutrons. Therefore 9 minus 4 is 5, 19 minus 9 is 10, 23 minus 11 is 12, 18 minus 8 is 10, and you're looking for equal number of electrons and neutrons. Equal number of electrons and neutrons, well, you can see that these are not equal. 4 is not equal to 5, 9 is not equal to 10, 10 is not equal to 12. D must be the answer. As you can see, 10 electrons equal to 10 neutrons as required by the question. Okay, so this kind of questions you kind of have to set up this kind of thing, proton, electrons and neutrons, very quickly and go through the options and yeah, not make any mistake at all. So that's it really on this work number 1 for atomic structure. And yeah, I'll see you in the next video. Don't forget to ask any questions if you got some, and move on to work 2. All right, see you in the next video. Thank you for watching.